Hi, my name is Kevin Burns, and I've been using a distributed key value store from a company called Basho. It's called Riak, and I wanted to show what it does differently and why it's so cool. I'm going to highlight one usage pattern, which is going to focus on two constraints from representational state transfer, self-descriptive messages and hypermedia as the engine of application state. So we're going to do an experiment. We're going to use Riak's link headers as type hints, and we're going to use JSON schema to describe the data that's the JSON objects that are stored in Riak. If you haven't heard of JSON schema is a JSON data format for describing JSON objects. So this here is a schema for product objects, and we know that each product has a number of properties, like an ID, a name, a price, and a tag. We know that a price is a number, and it's required, and the minimum is 0, so you can't have negative prices. These things allow you to format data that's coming from the server, and also to format data before it goes to the server, so that you know that the stuff that you're storing into your data store has at least some sort of uniformity. I think the best way to describe this pattern is probably as conversation. So in this case, we're going to say that your client is Robocop and Old McDonald is a resource on the server that you're interested in. So we have a URL, and we're going to go ahead and get it, and what we get back is a JSON object. And along with this JSON object, we also get some link headers, which are a part of Riak. So we get described by link header, a pet, and a farm. So we know that this resource has a pet, this resource has a farm, and this resource is described by this resource over here. So in order to really understand what this object means, we need to get the schema, because we don't know if this is a person or if it's a cow, or we don't know what this object is. So when we get the schema, what we get back is a JSON schema that describes that object. We know that every person, we know that it's a person. We know that every person is of species Homo sapien. We know that every person has a number of arms and legs, and the default is 2. Not everybody has 2 arms and 2 legs. And we also know that every person is an animal. So in order to really understand what a person is, we also have to understand what an animal is. So now we're going to get the animal schema. Every animal has a species and a name. And once we combine that with the person schema, then we can really understand what Old McDonald really is. So once we've done that, we're going to go ahead and we're going to follow some links. So now let's take a look at Old McDonald's farm. So we had that URL. We're going to go ahead and get that URL that was linked to in the link header. And what we get back is another JSON object. We don't know what this is. We just know it's a JSON object. We know it's described by this resource over here. So let's go ahead and get the schema. So we get schema, and we see that it's a location, and that every location has a latitude and longitude and a name. In this case, the name is Old McDonald's farm, and the location is someplace in Texas. There are also a number of animals on the farm, and the farm has a number of mortgages. Looks like Old McDonald had to take out a second mortgage. So we're going to get one of these animals. We'll start with Bessie. Let's see. So we're getting the second animal. What do we get back? Oh, we got back an object. Okay. What's that mean? We don't know. Well, it's described by the schema over here. Let's get that schema and see what we're looking at. Schema is of type cow. Okay, Bessie's a cow. Cool. Every cow is either a steer cow or a dairy cow, and every cow has 4 legs. Well, most cows have 4 legs. So that's great. Now we know what Bessie is. Let's go back and let's follow some more links. Now we're going to follow his pet. We saw up above that Old McDonald has a pet. We don't know what kind of pet it is. It could be a rock. We don't know. So we're gonna get that. We're gonna get Trixie, and what we get back is an Australian Shepherd. Cool. What is that? We don't know. We'll have to get the schema. We get the schema. What is it? It's a dog. Cool. Okay. Trixie is a dog. Dog is also an animal. We already know what an animal is. Cool. That's about it. So what you get by implementing this and not assuming anything about URLs is you can create, it's this loose typing, more loosely coupled components. And you also get heterogeneous buckets. So that's it. Have fun.